ASP.NET Core applications can leverage built-in framework services by injecting them into methods in the startup class. And you can configure application services for injection as well. The default services container that's provided by ASP.NET Core provides a minimal feature set, but as with many features in .NET, you can plug in your own container if you need something more robust. And there's a number of third-party dependency injection containers that you can use within .NET Core applications. Okay, so what exactly is dependency injection from the perspective of an ASP.NET application? Well, what it does is it lets you inject framework services, or other kinds of services, custom services included, into classes and methods, making it easy to change the implementation of those services. Really what it boils down to is it provides loose coupling between objects and their collaborators. So dependency injection is a technique for achieving loose coupling. And those objects are often called collaborators, or what I think is better referred to as dependencies. What the object, in this case, really the context in which we're talking about dependency injection, is the startup object. So what objects does startup collaborate with or depend upon? And those objects are what are injected into the startup class, or any other class that you might use dependency injection. For example, it's very common to inject entity framework services through the context object into your controller class. Okay, so what this means is that code no longer needs to directly instantiate collaborators or use static references. You don't have to new up these objects, which creates a strong coupling to that concrete class. So rather than directly instantiating collaborators or using static references, both of which creates a close coupling, the objects a class needs in order to perform its actions are provided to the class in a bit more indirect way. Most of the times, classes will declare their dependencies via the constructor, and that's called constructor injection. When classes are designed with dependency injection in mind, they're more loosely coupled because they don't have direct hard-coded dependencies on their dependent objects, or the objects that they're dependent upon. So instead of referencing specific implementations of those services, classes instead request abstractions, which are typically in the form of an interface, which are provided to them when the class is constructed. And then you can also extract dependencies into interfaces and provide implementations of these interfaces as method parameters. And both of those techniques are used within the startup class. And there's also a form of dependency injection for properties, but that form tends to be much less common, at least in .NET. Now, when you inject a dependency as an interface into a constructor or method, the runtime needs to know what concrete class it should use. That is all part of defining the services that are available to the application, which is what the optional configure services method in the startup class does. And so we'll visit that code shortly again to see how that works specifically in the context of dependency injection. Now, ASP.NET Core includes a simple built-in container that I mentioned, and it's represented by the iServiceProvider interface. ASP.NET Core's container refers to the types it manages as services. So you can kind of see how the terminology is all coming together. And again, you configure the built-in container services in the configure services method within the startup class. Before we get back into the code of the startup object within the sample application, I want to point out a couple of really good articles, pretty timeless articles about dependency injection. So this first one that I show here from Martin Fowler, and it's called Inversion of Control Containers and the Dependency Injection Pattern. This is a really good, very readable kind of an article. As you see, it dates back to 2004, so well over a decade ago. And it lays out how dependency injection works in the early days of when this was really becoming a pattern that was starting to be adopted widely. And the nice thing about this one is that even though it's based on Java, talking about J2EE and so forth, he goes through and talks about different kinds of achieving this loose coupling that we're talking about. And so he has a very simple movie-based sample application. And if you know C#, the Java is going to be pretty understandable. But this article really has been proven to be timeless. You'll find as you research dependency injection on the web and come up with various articles, and even on Microsoft's site, almost always they're going to reference back to this article because it's really kind of canonical about the description of how dependency injection works and making a case for it in a well-designed application. So it's well worth a read. Might take a couple times to go through and fully grok everything. He does talk about a service locator here that's a little bit less relevant to ASP.NET Core, but it is interesting to understand the different techniques that you can use to achieve this loose coupling that we're going for with inversion of control or dependency injection. Okay, then the second article is from Microsoft's Patterns and Practices group. And so this is another real good description of it. I guess it goes back to 2013, so a much more recent article. But it does describe things, particularly talking about factories, kind of in the context of C# as opposed to Java. So if you really want to learn more about the concepts of dependency injection, I would first start with Martin Fowler's article, the first one I showed you, and then come for the Microsoft stack and read this one for a little bit different perspective. And I rather suspect by the time you go through both of these, you'll have a pretty good understanding of at least the concepts of dependency injection. Because what's really good news is that the implementation of it in ASP.NET Core is really rather elegant. I think they did an excellent job with all this. Okay, so I've covered some of this before, but now focusing on dependency injection. So the first major place is within the constructor for the startup class. And as we've talked about, there's an iHosting environment object that is injected into the constructor, which then becomes available throughout the class, depending on whether you save a reference to it or not. In this particular case, the code isn't saving a reference to it, but it's using it directly in order to work with the configuration builder, build up that configuration, save those different settings to make them available as part of the configuration property of this startup class, which is then used as much as you want throughout the class. So that's a very common thing to do, is particularly within your controller classes. If you're going to inject entity framework within the controller, then you might have a private variable or a field that the entity framework is injected in the constructor, and then you save a reference to that object in that private variable. And so that way you can use that context of entity framework throughout your application, all of the action methods and so forth. So it makes a really nice interface, very simple to implement. Okay, and so it uses that and checks to see if it's development and adds user secrets and so forth, and then ends up with the configuration information stored in the configuration property. Okay, then next up is configure services, and this has injected the iService collection object of services. So this specifies the contract for a collection of service descriptors. This injected object is what you use to define the services used by the application, including things like entity framework and MVC and so forth. So initially, when this object is injected into the class, it has just a handful of services defined, some of the internal stuff, all of the background stuff that ASP.NET Core needs itself. And then the configure services method, which is part of the project template that I created this application from, adds services using add DB context, add entity framework, add identity to add authentication, and add MVC in order to add the features of an MVC application. And those are all extension methods. Now the features and middleware that are provided by ASP.NET Core, things like MVC, follow a convention of using a single add whatever, add service name extension method to register all of the services required by that feature. So there's a lot going on behind the scenes when you use add DB context, add identity, and add MVC. And there's various other ones. And that would be a good convention for you to use if you're going to add your own custom services to your applications. Okay, and then this method also registers 2 custom services. These add transient methods specify the specific objects for dependency injection when injecting a particular interface. So when you inject the iEmail sender using that interface right there, then the application should use this specific object. So this is the concrete object that wherever you're injecting this object into is going to have access to. It's a concrete object in memory. It's not just an interface. So this is how you can add your own custom objects that you use for dependency injection. And there are different options depending on the lifetime that is appropriate for each kind of service. And I'll be talking about dependency injection lifetime a little bit later. Okay, so just to make this complete, let's go look at the definition of the interface. So that's iEmail sender. As you can see, it has a single method, send email async. It's all asynchronous, but it's just an interface. And then if I look at the concrete implementation of it, I can go to this definition, and now I have an actual class that happens to implement both of these interfaces that are used up in the startup class here. So it's the same object that is used by both of those services. And then you can see that it implements both the send email async and the send SMS async methods. Okay? So those are the 2 methods that are required, one for each of those interfaces. Now, you can register services with the dependency injection container in several different ways. The code in configure services, this code here, registers a service implementation with a given type by specifying the concrete type to use. Or you can use a factory, which will then be used to create the instance on demand. And that technique is talked about in both of those articles that I pointed out to you. The third way is to directly specify the instance of the type to use, in which case the container will never attempt to create the instance itself. Now, so the first 2 methods really are most common. And in fact, the first one is what is used here within the startup object within the ASP.NET Core application.